This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Welcome to yet another episode of Software Engineering Radio. My name is Sven, and today I'm sitting here with Simon Fraun. And Simon is an independent consultant and trainer and the creator of the C4 software architecture model. He also wrote a book, Software Architecture for Developers. How are you, Simon?
I'm very good, thank you. You?
Good. Also very good.
Excellent.
Anything to add?
No, I mean, as you said, I'm an independent consultant. My background is actually in consulting and building software, mostly in London and mostly in Java for banks. So that's kind of my software development background. But over the past few years, I've been jetting around and really doing lots of consulting, training, and helping teams understand what software architecture is and how they can blend it with lightweight, agile ways of working.
Okay. You're proposing sketching as an effective way of creating and communicating software architecture. So, first of all, why communicating software architecture?
If you look back, say, 10, 20 years, we used to have a very process-heavy, document-heavy, high-ceremony way of doing design. So this is the go capture all the requirements, do all the design, and then document that design in a big, chunky, hefty document. And then UML came along, and everybody was buying UML tools and modeling tools, and we were spending months and months and months just doing design. Fast forward to 12 years ago, and the whole Agile thing came along. And I think we've gone from one extreme right back to the other extreme, where lots of teams are basically doing nothing. So what I'm trying to do is I'm trying to push the needle somewhere back towards the middle.
We had big design up front, then no design up front, and
right.
Now you're trying to get the just enough.
Yeah, and of course Agile doesn't say don't do design, but that's many people's interpretation of what the Agile Manifesto and Agile approaches say, but that's not actually the case. Mm-hmm. So yeah, I'm trying to get people thinking about design again, and I'm trying to provide a nice lightweight mechanism that people can use to share these ideas. Because after all, you have this fantastic idea for how to build a software system, and the team needs to understand it. And really, that's the whole purpose of sketching. Okay,
so the stakeholders of the architecture is the team.
Right. Software developers, we are the biggest stakeholders of software architecture. Mm. So that's the primary audience who I'm targeting, for example, these sketches at.
Okay. What are the benefits of sketches?
What are the benefits of sketches? It's really about being able to communicate and share that vision that we create of, this design or this architecture of the thing we want to build. And the thing about sketching is that it implies a certain degree of lightweightness, if that's a word. And what I'm trying to avoid is going into this big model-driven upfront design process where we have to think through lots of things. And really this is about getting the majority of ideas down quickly in a way that's accessible to developers.
Okay, so it's okay to leave stuff out. It's better to be incomplete, but lightweight.
Yeah, so we're definitely looking for some preciseness here, especially around some of the high levels of abstraction. But what I don't want to do, for example, is drop down to class level details. Mm. So if people are sketching out class diagrams, maybe we have to question why and what the value of doing that is.
Exactly. Yeah. Sketches are not formalized, and so there are probably many ways I can create a sketch, and especially ineffective sketches. So what is a bad sketch or an ineffective sketch?
What is a bad sketch? What is an ineffective sketch? So that there are lots and lots of answers there. Part of the workshop that I do is I get people to design a solution and draw some pictures, and I don't give them much guidance at all. And I would say probably upwards of 90% of those sketches are ineffective. They're ineffective for a number of reasons. First of all is the notational side of things. So people don't tend to use UML, and UML is a standardized, formalized notation. But if people are not using UML, then they're essentially inventing their own abstractions and notation. And that causes a lot of confusion, as I'm sure you can imagine. And as well as the notation, it is really those abstractions. So we find lots of sketches with mixed abstractions, mixed levels of detail, where people have drawn multiple sketches to show different views of the architecture. It's not clear what the relationship between those different sketches is, for example.
Mm-hmm. I can imagine when I studied, my software architecture professor always made fun of architecture.
Architecture.
Even if you go to the Oracle website and you look at the architecture of the JDK, it's just boxes with some colors, for instance.
Right, yeah. Normally nice and gradient shaded, so it looks nice, in Oracle color schemes or something.
Yeah, but then you don't know what the screen means, and exactly.
No.
Yeah. Okay, you mentioned UML, and I'm just wondering, is UML and the tools around UML, are they dead? Nobody talks about it. I mean, sometimes people even don't know what UML is anymore.
That's very true. I think there are some universities who are no longer teaching people UML. From my perspective, I do still use UML, but I use it very, very sparingly. And I use a very small number of UML diagrams for a very specific reason. So class diagrams for showing classes and how they interact. I like activity diagrams to show workflows, and that kind of fits. State charts for states, and sequence and collaboration diagrams if you want to show interactions between things. But that's pretty much it. I don't use UML for the kind of quote-unquote architecture diagrams, and I don't see many people using UML tooling anymore. One of the questions I regularly ask my audiences at talks and workshops is, how many people here use UML? And I've asked this question in the United States and half of Europe and China and Australia and Dubai, and it's about 1 out of 10 people.
Okay.
I've recently had a bunch of audience where it's been 0 people.
Oh.
So is UML dead? I think the numbers probably point to it being dead.
Okay. So
it's a depressing thought.
Yeah, I mean, at least it's a lot of ideas are not dead, but it's probably just a notation, and where people just don't want to dive into it.
Yeah, it's just too complex.
Yeah, you mean because it grows so much, or
yeah, I mean, how many diagram types are there now? Like 20 or something? I honestly couldn't tell you.
I lost sight after 1.4. I think after that it was just too much.
Yeah, the best UML book I've ever read was Martin Fowler's. I think it was UML 1.1 distilled, which is what, like 15 years ago or something. That was the best book on the whole topic.
Okay. Okay, let's go to the C4 model. First, I just want to ask you, you mentioned Schneiderman's mantra. So who is Ben Schneiderman and what is his mantra?
That's a very good question. So I don't actually know who he is. But his mantra is basically, it's a way to deal with lots and lots of data. And this was recently introduced to me by one of the other speakers at a conference I attended. And essentially, if you have a huge amount of stuff to deal with, what you want to do first is get an overview. Then you want to zoom and filter. So you're kind of dropping down into a subset of the data set. And then if you want more information, you can get that on demand. So what has this got to do with anything? So the C4 model is basically a way of very, very simply describing a software system. And in order to understand the C4 model, you need to kind of backtrack slightly and say, well, how do you represent and think about a software system? So a software system for me is made up of a number of containers. These are basically deployable or executable units, something that you can host code or data in. Those containers contain components. What's a component? It's just a bunch of stuff related, highly cohesive, with a nice clean interface. And because I deal with Java and .NET, my components are made up of classes. And then once you understand that simple tree structure, so system, containers, components, classes, you can then draw a diagram at each level in turn. So start with the system context picture, which basically says, here's my system in the middle, and around it are my different types of users and system dependencies. You then open up the system to show the containers inside it. You then open up each interesting container to show the components, and then optionally you can open up the component to show the classes. So the C4s are context, containers, components, classes. So to come back to Snyderman's mantra, the overview first I'd consider to be the context and containers pictures, because that gives you a nice starting point. Zoom and filter is kind of zooming into one container and looking at the components inside it. And then details on demand for me is the class diagrams.
Okay. And so the context diagram, it shows users, the system, and the system it's collaborating with?
Yes, yeah, exactly. So it's normally, very simply, the system you're working on, your key different types of users. You can call them actors or roles or personas, entirely up to you. And then, as you said, it's your key system collaborations. So everything from systems you send data to, systems you get data from, your Active Directory server, your email server, your monitoring system, all of those sorts of things.
And stakeholders of that diagram?
Stakeholders are basically everybody. So everybody from people paying, business people, through to us as developers, so we can get a starting point for why we're building this system and really how it fits into the rest of our environment. Technical people, operations, support, maintenance. There's basically that diagram is useful for everybody. It's just a really nice, simple starting point.
Okay. Then the container. When I hear container these days, I always think about Docker.
Docker, yes. It's a diagram showing Docker. No.
So is it the same? What you mean with a container is the same what the Docker thinks a container is?
The simple answer is possibly. So let's imagine that you are building a system and it's made up of a web server talking to a database. How would you deploy that in terms of Docker containers? We might have a Docker container for the database and a bunch of Docker containers for your web server. So in that sense, it kind of matches up. So what I mean by a container is something that can host code or data. Essentially, it's a separately deployable thing. So web server, application server, Windows service, standalone application, browser, mobile client, any of those sorts of things.
Okay. And then it also contains, the diagram contains technology choices, or?
Yeah, so my typical containers diagram, this is kind of hard to show on a podcast without visuals. But if you take the context diagram, basically you're just zooming into your system. And it really just shows, the interaction between, let's say, your mobile app talking to your website, talking to a database, storing stuff in a file system, whatever it is that your system's made up of. It's only showing logical containers. So imagine I'm storing data in a MySQL database and it's actually a cluster at deployment time. I don't want to show a whole cluster of servers. I'm just showing one logical MySQL database. And it has tech choices on. So if it's a MySQL database, I'm going to say this is a MySQL database.
Okay. So what do I? Oh, Uncle Bob said the web is an implementation detail and not part of the architecture. Why should I then include technology choices?
The web is an implementation detail. I totally get where he's coming from here. So let's answer the other question first because it's simpler. Why should I show technology choices on my containers picture? Because ultimately I have to build and deploy and support this thing at some point. If we're building let's say we're going to build this web app and we need to store data somewhere, we are going to have to choose a database. We're going to have to choose a web server. We're going to have to choose a programming language. So there are some choices that we must make up front. And my containers picture, if I'm drawing a containers picture as part of my upfront design exercise, maybe the technology choice has not been decided, so maybe we just list out options. But if we're drawing a containers diagram retrospectively to describe an existing system, then there's no reason not to put the tech choices on. So the major reason why I like putting tech choices on architecture pictures is that it brings the architecture pictures back down to earth again. I'm sure you've seen this yourself when you flick through documentation in large organizations and they have all these nice fluffy architecture pictures and it's just nebulous terms. It's just conceptual blobs kind of floating around talking to one another. Once you start to put tech choices on, from my perspective as a developer, I can start to really see and visualize and understand how that thing works in the real world.
Yeah, you probably need some. For me, it's important to have some traceability between fluffy diagrams, or let's say from diagrams to code. And if it's just too high level, then I don't. Then it's really hard to trace it.
Right. Yeah. So those diagrams need to have some value, some use.
Yeah. And the stakeholders of the container.
Stakeholders of the container diagram are definitely us as developers, because that allows us to kind of step back from the feature we're building and look at the entire system and how it hangs together, and also operations and support staff, by which I mean people who are not necessarily developers but who are going to be running and operating and maintaining your system. And often those people have a technical background because they're dealing with infrastructure and provisioning services, and they do want to know some technical knowledge, but they don't necessarily want to know how your code is structured. So they want to know there's a web server talking to a database with a firewall in between, but they don't really care what's inside your web server.
But operations people probably care, do I have only one instance of this thingy or N instances?
Yeah.
So do you add that also then to the diagram, that you at least say, this is, can have one or many?
So normally, no. I try to leave my containers diagram just showing the logical static structure. And I'll have a separate diagram which talks about how we map that onto infrastructure. So this is where we have, you have one server and it's deployed across this farm of 10 servers and this database cluster.
Okay. But it's not part of the C4.
No,
it's the C4 plus. So.
C4 plus plus.
Okay. Yeah, we come back to that one.
No worries.
Okay. So first, maybe we can go to the components. So what is a component in C4?
I've adopted the simplest meaning of component I think I possibly could. And basically, it's a bunch of related stuff with a nice clean interface on top. Now, I don't really want to get involved in discussions around how people decompose their systems and come up with a list of components. That's entirely up to the design process and the preferences that they have. So all I mean by component is a bunch of related stuff with a nice clean interface. So for example, this could be something like a logging component, which could wrap up Log4j or Commons logging. We could call that a component, quote unquote, because it has a task, it has a set of responsibilities, and I can create a nice clean interface on top. One of the things I talk about in my book is a simple financial risk system. I have a bunch of requirements in there. So if we were doing component level design for the risk system, maybe you'd have a risk calculator component, which does all the heavy lifting, the calculations. Maybe there are some data importer components. Maybe there's a data merge component. Maybe there's an alerting and monitoring component. So it's that kind of granularity of stuff.
Okay, and how do I know? Is it only a drawing, or do you also have then text? Because from another method, I know for every component, you just say, this component needs as an input something from other components, and it exposes this and that.
Yeah. So if you look at UML does have a component diagram, and there are a couple of varying notations. One's got the two boxes sticking out of one side of the box, and one's got the a cup and ball notation for interface and consuming the interface, depending on the interface. I find people struggle with that notation. So I keep the notation very simple. And on the components diagram, each component is just a box. There's a component name. There's optionally a description of the technology choice. Again, if it's being implemented already, we can fill that in. And I draft a list of responsibilities just to give a flavour of what that component is doing. And there are a number of reasons for adding responsibilities in the diagram, but firstly, and I guess more fundamentally, it allows you to have a quick at-a-glance view at a diagram and see how your responsibilities are carved up across your components. In terms of the relationships, I just draw them as single line, single arrows, and I normally show a dependency or using style relationship. So if component A depends on component B, I'll draw a line from A to B with an arrow pointing towards B and a little annotation on the line saying depends on or uses data from or something like that.
Okay, and the depends on this. Since we have no notation, everybody comes up with their own notation. It's important to also say, oh, this is not just an arrow.
Right. Yeah. So if you look at my arrows on my diagrams, they're pretty much all unidirectional, so they point one way, and they're all annotated on the line. So hopefully the direction of the arrow and the annotation match up to explain what that relationship's for.
If I now zoom into my container and I see all my components in the container, I probably have redundancy because there are some shared components, between containers.
Yeah.
So these ones I have to draw basically double and also mark that it's used elsewhere, or does it?
Yeah. So let's say that we're building a system, and let's say that there's a web application serving users, and let's say there's an API server which is serving automated clients. And let's say that there's a shared audit or logging component that's used within both. Same code base, same technology. So I would draw both of those, say audit and logging components in both boxes, and just maybe annotate to say, actually, this is coming from a shared library that we're in control of.
Okay.
So again, just adding hints to the diagram to portray more information if needed.
But then if I draw all these diagrams, I can imagine when I do it, and I have shared libraries, and then I think, now I understand it much better. And I was wrong in all my diagrams, or in a lot of diagrams, and then what do I do then? Because probably I do, after the sketch, I make a photo.
Right.
And then I have to redraw all of them again?
Yes. So this is where we transition from sketches to something a bit more formalized. And historically, we've done this by opening up Visio or PowerPoint and kind of looking at the sketches we have on the walls and drawing boxes in PowerPoint and Visio to match. And that's an option. I've done that a lot in the past. But what I'm trying to do now is I'm trying to come up with a way where we can create software architecture models as code. So you'll notice I'm using the word model there. The C4 diagrams are based upon an underlying model. So this is the system, containers, components, classes. So what I'm trying to do is provide a way so people can write simple code to reconstruct that model, and then we can visualize it. So essentially, if you go onto my website, Coding in Architecture, there are a bunch of blog posts about it. It's called Structurizer. So essentially, there's a Java implementation sitting on GitHub at the moment, and it's a bunch of Java classes. So there's Java implementation, and there are a bunch of Java classes, and those Java classes represent things like systems, containers, components, and the relationships between those things. And basically what you do is you write a short little bit of Java code to say, right, I'm going to model my system. So you do software system X equals new software system, person Y equals new person Y dot uses system X, and you kind of build up the underlying model behind the diagram.
Oh, okay. Now I got it. So
right.
It's in the beginning I thought, because I've seen that before, that you have annotations, for instance, and then you have a re-engineering tool, and the re-engineering tool is trying to abstract everything, but what you're saying is you basically program your model
with code.
Yeah.
So once you create the model, then there are a bunch of other classes. One's called a system context view, one's called a containers view, one's called a components view, and then you can create those things. You can put bits of the model into the view, and then that's essentially a programmatic representation of the diagrams that you draw.
Okay.
So that's half the story. So that allows you to build the model up. You still need to visualize it, and that's why I'm building a diagramming tool which lets you visualize these models. So coming back to your other question about essentially, you create a sketch, you start writing some code, you realize your sketch is wrong because you've got some feedback and you've learned some stuff. How do you keep the diagrams up to date? So what I'm also trying to do is add in some code that will automatically extract, in this case, components out of your code base and allow you to automatically populate that architecture model using your code base.
Okay. Before I come back to that one,
Yep.
Was the programming, the model, was that influenced by architecture, ADLs, architecture definition languages? Is it something like this? I don't know what an ADL is, but I only know the name.
Architecture description languages. I've never really seen these used in the wild. I've read bits about them, mostly in kind of academic circles, but I've never ever really seen people use them. So in answer to your question, was the software architecture as code influenced by ADLs? The answer is no. I'll be brutally honest and tell you where the idea came from. So this diagram tool I'm creating, I wanted to build a really simple diagramming tool where, as a user, all you needed to do was drag boxes around. In order to do that, you needed the underlying model. And this thing called Structurizer starts out life as basically a web application where you would fire up and you would get a whole bunch of HTML forms where you could enter all the names of your systems, enter all the names of your actors, enter all the names of your containers, enter all the names of your components, plug them all together, and then it would draw the diagrams. And it sucked. Right, the user experience was just awful because even for a small system, you had to go through all these HTML forms and pages to basically plug all the data in. Behind the scenes of that web application was this domain model. So there was a domain model representing systems and containers and components. And when I was playing around, I think I was writing some tests for that domain model, I thought actually this is a much better way to describe a software architecture, right? Just by using the domain model and wiring classes together. So I pulled it out of the web app, and that's basically what Structurizer is.
Okay. And the reverse engineering part, is that also something from what Structurizer offers?
Yes, yeah. So this is all part of the open source library. And if you look at what traditional diagramming tools do, and static analysis tools, what they do is you point them at your code base, and they say, right, I've analysed your code base for you. Here's a list of all your packages and all the dependencies between the packages, and then you kind of double-click the package and it shows you all the classes inside the package. I didn't want to do that because there are many types of classes in a typical software system that I really don't care about from an architecture perspective. So what I'm trying to do here is I'm trying to only extract the architecturally significant building blocks, in other words, the components from the code base. So the question becomes, how do you identify things that are significant versus those that are not? And it's entirely up to you. This is a short answer. But what I normally find is, if you look at a typical enterprise Java code base, people will name things using a naming convention, sometimes unconsciously. So you'll scan through a Java enterprise system, and a bunch of the classes will be named something service or something module or something component. So let's use naming conventions to extract elements from the code base and call those our quote-unquote components. If you're using something like Spring MVC, so with Spring MVC, you use the Spring annotations to annotate, this is a web controller, this is a service, this is a repository. Great, so let's use those concepts and call those our components, and we'll extract those and pull them into the model.
Okay.
So there are almost different strategies depending on the system you're building and the languages that you're using, but it's that kind of concept rather than pulling out all of the utils and all the domain classes and all the implementations that we really don't care about.
Okay. Cross-cutting concerns like security or scalability. How do I map those to sketches?
The simple answer is you don't. So the sketches I focus on are just around the static structure, and I normally have either some other sketches or more often some text to describe how we deal with security, how we deal with scaling, auto logging, that sort of thing. So cross-cutting concerns, in my opinion, don't fit very well in diagrams.
Okay. C4, so we have context, containers, component classes. That's all static description of software architecture, but I might be interested in dynamic behavior. Is that then part of C4++?
Yeah, so it's C4++. So as you said, C4 is just the static structure, and that goes from classes through components, containers, and up to the system. Once you understand the static structure of the thing you have, either you want to have or you've built, you can then show collaboration diagrams or sequence diagrams that show the interaction between components, for example, to satisfy a feature or use case or user story. So that's what I'd rather do. I'd rather focus on getting the static structure understood and then use other techniques to supplement the static model with collaborations, runtime, behavioral diagrams, that sort of thing.
Yeah, so basically the major use cases are then modeled in an activity diagram.
Yeah. Activity diagram, collaboration diagram, that sort of thing.
And you also have then, you said, a deployment diagram?
Yeah, so other diagrams that may or may not be useful to describe your software system, everything from wireframes and UI mockups through to models of the business domain. So if I'm dealing with a complex business domain, I might have a bunch of very simple kind of domain models just to show the major domain elements and entities. Deployment diagrams, infrastructure diagrams, the runtime behavioral stuff that we've already talked about, and there are probably a couple others as well, which escape me a moment. But yeah, for me, the C4 stuff is about describing the static structure, and then you weave all the other diagrams around it.
Okay. Are there similar approaches to C4? Anything that inspired you?
Not really. This is pretty much the way that I've always thought about and therefore described software systems. So this has really come from just the way that I've worked. Since doing this, I've been pointed to a couple of other things which have some similarities. So there's something called SysML. I don't know if you've heard of SysML.
I heard about it, but never looked into it.
Yeah, so I looked into it briefly, and again, it's one of those things that I don't see people using in anger. I've come across maybe half a dozen people over the past couple of years who've used it. And somebody pointed me to ARC42. You've heard of ARC42?
I've heard of it, and I actually used it.
Right.
So, because it's two German guys.
Yes, yeah.
So when I saw the C4, I was like, that looks kind of ARC42. It's similarities.
Yeah, and I think there's an English version of the ARC42 documentation set available now, isn't there? And am I right in saying that it has different levels, so like level 0, level 1, level 2, or something? Is that right?
Yeah, I think so.
So yeah, I think some of the concepts are similar, but it's not something I've looked into heavily.
Okay.
It's on my to-do list now, the English stuff as well.
Okay, little wrap up. How do actually effective sketches look like? What do I have to do?
Effective sketches. So effective sketches are really simple. Number one, make sure that you and the team understands a common way of thinking. And what I mean by that is make sure you agree on a set of abstractions. So whether that's my C4 model, systems, containers, components, classes, or something else, it doesn't really matter, but make sure you as a team have a way to describe and think about software systems and you have a consistent vocabulary. Once you've done that, understand how you draw a diagram showing each of those things separately, and that's what the C4 model does. And in terms of the sketching, it's really simple. Just be conscious of notation. So if you're using different shapes, different colours, make sure you have a little key or legend in the corner to explain what that stuff means. Have a title on diagrams. Don't leave arrows unannotated. Make sure arrows go one way only. And it's all of that stuff. So just try to create as simple a notation as possible. And if you do need to highlight different elements, make sure it's explained in a key. This is basically what maps do. If we go get two maps of Amsterdam, they'll both show the same things, the same abstractions, but they might use different colours, notations, and symbols. Exactly the same concept.
Yeah. Okay.
The easiest way to do this is show someone else outside of your team the diagram, and if they say, "What does that mean?" then there's some more stuff you need to add.
And also maps show highlights, and
right,
you probably also want to show only the highlights.
Yeah.
Okay. Software architecture versus code. Why is it versus code?
Why is it versus code? Yeah. Because historically, this is software architecture and software development. Although they're really two sides of the same coin, they've always been competing forces. And you can see this with the ivory tower architects on one side and the software developers on the other, and the worlds never match. And I'll give you a really simple example. I've often seen teams with nice big architecture diagrams on their wall, and they have all these kind of grand terms and very fluffy conceptual boxes. Can you find those boxes in the code? Right, so if there's a bunch of components listed, how easy is it to find those components in the code base? And the answer is actually not all that often. And that's the versus bit, that's the conflict.
Yeah. Does the code ever match the diagrams? No.
Right. So why not? And therefore, how can we make it match the diagrams and vice versa?
So how can we do it?
So there are lots of ways to do it. The way I do it is again through the C4 model. So let's say we've opened up our web app and we're listing a bunch of components in our web app. What I want to do in my code base is I want to make sure I can explicitly find those components. George Fairbanks, who wrote a book called Just Enough Software Architecture, he calls this the model code gap. So in other words, when we have a model of our architecture on the wall and we have our code, there's a gap where these two things never meet. And he says very simply, all you need to do is adopt what he calls an architecturally evident coding style. So in other words, when you're coding, you drop in hints that portray your architectural intent. Examples being, this comes back to the naming convention thing. So if you're building a quote-unquote service or component or module, make sure some class somewhere or some interface has the word service or module or component in it. The approach I take is called package by component. So if you take a traditional enterprise Java system, there are a number of ways that you can structure and organize your code base. One is the kind of package by layer approach. So you have a web layer and you have a business layer and you have a data layer. And in the web layer, you've got controllers. In the business layer, you've got services. And in the data layer, you've got repositories and data access objects. There's a whole reason why perhaps we shouldn't do that. But that's horizontal layering. You've got vertical layering, which is package by feature. So you kind of relate the controllers, the services, and the data access object, and you align those to some functional group, maybe feature set, maybe domain concept, whatever it is. And I use a hybrid approach. So I keep my web stuff separate because that's presentation tier and it's going to potentially have a different volatility to the rest of the code base. And I structure my code base in terms of components.
So you do vertical slices of a feature, but the vertical slice has no. It's just a logical view on it. So if there is anything like a web front end, that's just an adapter on top of it.
Right. Yeah. So you can think of the web stuff as being a layer on top of a bunch of components, and then from your web controller perspective, for example, essentially you just wire in all the components that you need. So maybe you have a customer component and an order component and an audit component, and all of those things will be separate things in my code base. And what I do is I bundle up all of the classes, so the services, the business object, the data access object, into a single, in this case, Java package. I make the interface public, and I make all of the implementation details package protected.
But that means also I have to work very incrementally and always go back to the model, because I can imagine I do my models and then I start coding and then it's like, not as I thought. And then I have to go back and adapt the models to the code, and that's how it works? Or
Not so much. So but by model, do you mean like the view models that you use on the front end, for example?
No. I mean the for instance, a component view.
Right.
So I want to see my logical model in the code.
Yeah.
So I make my logical model.
Yeah.
And then I start coding. And then of course it's going to be very different, or at least different. And then I have to go back and adjust my models.
So by models, you mean the diagrams?
The diagrams, exactly.
Yeah. So that's the other reason why I'm trying to automatically scrape these components out of the code base, because then you just start coding and you run the tool and it recreates the model for you, the diagram model. So I take this package by component approach, and public interface, everything else is package protected, and that's all of the business logic and all of the data access logic. So essentially, what you've got is a component with layers inside it, rather than structuring your code base by a layer as the primary thing. And this is kind of nice because it brings back modularity to your world. So everything to do with the customer component sits in the single Java package.
Some popular technologies destroyed it back then, right? By introducing the controller service.
Yeah. And of course in Java, if you do the package by layer thing, in order for the layers above to talk to layers underneath, you need stuff public.
Mm.
And as soon as you start having lots of public classes in your code base, guess what happens? People find them and call them.
Yeah, of course.
So what this package by component thing does is it uses the Java access modifiers properly. I'm going to use air quotes around properly, so that if somebody wants access to my customer information, because the data access object is package protected, they can't get it. So they're forced to go through the public component interface.
Yeah, exactly. Yeah, layer bridging is more common than it should be.
Yes.
Okay. So we said when I'm sketching on a whiteboard, I shouldn't save the images somewhere in a document. I rather take the images in the code, and then I check it in. Is that my documentation?
So if I'm running a workshop, like a very early design workshop, and we come out with sketches, then I will also take some photos and keep those, either in my email or stick them on a wiki or a SharePoint server or whatever. But it's really when I want to start formalizing those diagrams, either for documentation or for sharing with teams that aren't located close by, then that's when I'll start to put them into Visio, or now I'll create a software architecture model with code. And if you do use the structurizer stuff and create a software architecture model as code is versionable, so you can check the model in alongside your code base. And then as part of your build process, you can run it, extract new concepts, check it back in again.
And you can see small changes, because with images it's probably hard to see what is the difference between A and B.
Yeah, especially if you're trying to run a diff tool against two video files. Yeah, it doesn't work very well, does it?
No. Okay, so Uncle Bob, he said once that the architecture should scream at me when I look at the code. And so you want to see the architecture in the code, and you don't want to see frameworks like Spring or Ruby on Rails, something like that.
No, so I actually agree with him there. So the architecture, and also when you open that code base, it should scream something about the domain that you're working in. And of course, that's what package by layer does not give you, because you see web stuff, then business stuff, then data access stuff. Sometimes you see framework names leak in there, like Hibernate, for example. And package by component and package by feature both give you a different perspective on the code base. Coming back to diagrams again, when you look at the container and component diagrams, although they do show tech choices, the tech choices are only really a small part of the diagram. You could scrub off all the tech choices, and you still have the name and crucially the set of responsibilities that each container or component does. And again, that's about screaming much more about the business domain than just having a bunch of technical boxes talking to one another. So yeah, I'm also a big fan of diagrams and code screaming something about the domain in which they operate.
Sorry, what?
So screaming about the domain in which they operate.
Okay, yeah, you don't want to see controllers, and you want to really see the domain in the.
Yeah, but of course I do want to be able to find the technology choices of when I need to. So if somebody's using Spring or Hibernate, I do want to be able to find that, but it's not my primary concern.
Okay. You wrote a whole chapter in your book on software architecture documentation. I don't know anybody who likes it, so why should we do that?
Because although we can focus on writing clean code and maintainable code and readable code, and we can refactor our methods so they fit on a page, and the methods fit in our head and all that sort of stuff, and we can say that the tests document some degree of what the code does. For me, the code doesn't tell the whole story. That's the fundamental point here. The code tells you how it works. It doesn't tell you why it works in that way. It doesn't tell you the rationale for crafting up a design in a certain way.
Okay. So the documentation is not only about the diagrams, it's also about decisions
Yeah. So it's decisions, it's rationale, it's what were the architectural drivers that led us to this design. Particularly lists of non-functionals. It's how do you maintain it, support it, operate it. How are you dealing with security? It's all of that stuff weaved into a lightweight software guidebook, I call it. It's kind of like, and I can't take credit for this, but somebody described it as the Haynes manual for your software. So there's a series of books, I think it's in the UK, called the Haynes manual, and basically it tells you how to take your car apart. It's the same sort of thing. So this guidebook tells you not how to take your software apart, but how your software works, and the rationale that went into it. It's akin to a travel guidebook. If you go on holiday somewhere, you don't want to know everything there is to know about the country you're visiting, but you want to know select things. You want to know the important highlights, the sites, the points of interest. That's really what this lightweight documentation is all about.
Okay, so I basically don't create a large software architecture document with everything. I just the things everybody should understand major technology decisions maybe.
Right. It's the Schneiderman's mantra again. So overview first, zoom and filter, and then details on demand we can get from the code. So one of the things I find people do is they write lots of really low-level implementation details as documentation. If you think about that for a second, who's the audience? It's us as developers. But we know where to get that if we know where to look. So the lightweight documentation it's a supplementary piece of documentation to help you navigate a code base.
Okay.
Ideally, something you can read in like 1 or 2 hours.
So
ideally, something you can read in 1 or 2 hours, maybe.
Okay.
Just to get a nice overview, and then you dive into the code.
And you mentioned maps and sites and history and culture and practical information.
Yeah.
What is a site then?
A site. So what I mean by a site is a point of interest. So you come to Amsterdam and there are a few places you should go visit, and the rest of the streets you can ignore. If you look at, so let's take a web application, and let's say that the web application has 200 different pages that users can interact with. Do you want to document all those 200 pages? And the answer is no. But what you do want to document is the points of interest, the sites. And for me, that's really the core repeating patterns that we see over and over again. So maybe out of those 200 pages, there are 4, 5, 6 interesting patterns repeated a number of times. So let's document the patterns and forget the rest.
Is in software architecture terms, I know the term texture. So texture is the repeating way of doing certain things. Is that also what a site could be?
So I'm thinking more of principles here. So the underlying architectural principles and styles. So things like usage of WebMVC, maybe usage where you've got some asynchronous data coming back to the browser. That's an interesting pattern to capture.
Okay.
So it's really types of ways of doing things. I'm not sure whether that's the same as the textures thing.
Yeah, the texture is, for instance, as I learned it, or we offer a web service, and then there is always one way of doing a certain type of web service, or there is if you understand one web service, you understand the principle of every web service, or one batch.
Same thing. Yeah.
Okay, which of course means you have to agree on the standards, but
Right, which of course you should do. You should try and agree some, let's call them principles rather than standards, but some principles before you start writing massive amounts of code. Otherwise, you'll get inconsistency.
I know that.
Yeah, we've all been there, done that.
History and culture. What's history and culture?
History and culture is really, how did we get to where we are? So, I'm thinking about things like, what are the key architectural drivers, the key requirements, the key quality attributes, the key constraints at the time. Many organizations say you must use this version of WebSphere and this version of Java. And then 3 years later, somebody comes in and says, why are you idiots using this version? It's so out of date. And then you say, well, that's part of the history and how we got here. And culture is really the development principles that we all adopt and use on a daily basis.
Yeah, I know that from people asking me, why the hell did you do it like this? And then it's like, I have to explain it again, because we had these non-functional requirements, and that's the whole reason. Okay.
Yeah. The example I give is if you ever go to Jersey, where I live, there's a really nice castle, which is it's a little island by itself. It's called Elizabeth Castle, and I think it was built in the 15th or 16th or 17th century. It's really kind of an old granite castle, and if you go and visit there, you've got this kind of beautiful stone architecture, and then someone stuck a big concrete thing on top. Like it's a really, really ugly concrete building, literally stuck right on top of the castle. And you walk around it and you think, why on earth is that ugly concrete thing on top? And then you read the history, I get it. And basically when Jersey was occupied in World War II, the Germans came along and refortified the existing fortifications. Again, it's part of the history. There's a story to be told there.
But is then a decision log? Is decision log then the same than history and culture?
Yeah, so if we have to evaluate different choices, then that's what I'll keep in the decision log. So there's definitely some overlap there. But maybe it's just about, we evaluated these products and this one wasn't suitable for these reasons.
Okay, so decision log is only about technology choices, but not about architectural choices?
Both. So it could be architectural choices, which may be based upon spikes or proof of concept work. It could be choices made relating to the skills of the team. So we chose to use this technology because we didn't have any other developers who knew technology. Why? Okay. All of that stuff just needs to be kept somewhere.
Okay. The decision log and all these kind of things, I'm just wondering, how do I write it, maintain it, and make it searchable? Because the decision log is really something I'm interested in. But is it that big that I have to bother, or is it probably just a couple of pages?
As short as you can possibly get it.
Okay.
So a couple of pages sounds perfect to me. And, there's nothing saying that this must be in a Microsoft Word document. You can stick on a wiki if you want to. You can take my guidebook structure and create one page per section on a wiki. And that's fine, it's all searchable. How do you keep up to date? Just do it incrementally. So if you have like a definition done for your tasks, for your user stories, whatever, you add a line at the bottom that says, have you updated the documentation and the diagrams if needed?
Okay. Yeah.
And then it's like 2 minutes work rather than someone like me sitting around at the end of the project for 3 months or just writing documentation.
Yeah, exactly. Oh, that's a good one. Yeah.
That's it. It's as simple as that.
Then nobody forgets it. And it's also getting reviewed if you do it.
Yeah.
Okay.
Yeah. Hopefully nobody forgets it.
Yeah, okay. Is there anything important I forgot to ask?
Is there anything important that you forgot to ask? I think what we've discussed covers a lot of the technical aspects, so diagramming, thinking about architecture, documenting it, all that sort of thing. There are lots of questions around the role of architects. Is the ivory tower architecture thing a good thing? Should we go for something more collaborative? My general approach is architects should write code. Probably should come as no surprise since my website is called Coding the Architecture. And for me, it's a very hands-on collaborative role, helping team members, coaching, mentoring, that sort of thing. A really interesting book published recently by Patrick Qua. It's called Talking with Tech Leads. Patrick's definition of a tech lead is basically someone who's leading the team, so setting the technical vision, answering all the technical questions, but still writing code. I think it's just 30% of the time. So what he calls a tech lead is what I call a kind of hands-on pragmatic software architect.
Okay.
And that's I think the other major area here. So it's just how to effectively lead a team from an architectural or technical perspective, but stay part of the team.
Oh, okay, interesting. I just thought I heard about the book, and I thought it was more of the general team leads.
Right. No, it's definitely focused on tech leads.
Okay.
And it's a fascinating book actually. There are lots of really interesting stories from people who are new to the role and people who have much more experience. And there were some really interesting recurring themes: time management, stepping away from the keyboard, not entirely, but to attend all the meetings and do all of the other stuff, and really just dealing with people. There's a whole soft skills element there that nobody really talks about, and I think that's what's great about Patrick's book.
Soft stuff is the hard stuff.
Soft stuff is always the hard stuff. Yeah.
Okay. How can the listeners find out more? Website, book, video, training, conferences?
all of those things. So the easiest thing is to just Google me. I normally come up on the first page of Google, but codingthearchitecture.com is the best starting point for all of this. So that's our blog. And there are links to the books. So if you go to LeanPub and do a search for software architecture, you'll find the book. It's called Software Architecture for Developers. There's an online training course on parlays.com, which is everything you get in the kind of standard 2-day course without all of the interaction and workshopping and diagramming stuff. And I'm usually at conferences all around the place. So I've got a bunch of conferences scheduled in Europe, and I'm going to the US on Saturday and going to the O'Reilly Software Architecture Conference in Boston. And then I'm back to the US in April for the Saturn conference.
Oh, okay.
So
nice.
yeah, lots of conferences, lots of traveling.
Okay. Thank you, Simon, for being on the show. I want to mention that the feedback of the listeners is very important to us, so please help us improving our show and leave your opinion via Twitter, Google+, or LinkedIn. This is Sven Johann for Software Engineering Radio.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.